RBS Busy Research Academy welcomes to you in the video number 15, part 2. Dear friends, in this video, I will discuss about the remaining three parts or three steps of the structural model assessment procedure. Dear friends, you are looking here exhibit 6.1, where all the six steps of the measuring the structural model assessment procedures are available. First three parts I have discussed in the video number 15, part 1. Its link is available below this video. And the remaining three parts, step number 4, assess the F square effect size. And step 5, assess the predictive relevance of the Q square. And last, step number 6, assess the Q square effect size. So these three steps I'm going to discuss in this video in the part number 2. Dear friends, as you know that in the structural model, there are two models are. One is the measurement model, and it has two types. One is a formative and the reflective. Another one is your structural part. The both are looking in this image. So now in this video, I'm going to I have discussed about the structural part. Before starting formally, I would like to introduce myself. My name is Dr. Handwritten Formula, and I'm from Shabati University, Pakistan. Dear friends, you are looking this my certificate, which has been awarded to me by the Smart PLS Academy, Germany, from where I completed this online course on the Smart PLS. Let's start our discussion. So first of all, the first step is number 4. In this video, that is about the effect size. So, dear friends, this is my practice. Usually, I provide some theoretical background and then I go on the practical. So, the first some theoretical background I want to present about the effect size. So, before understanding the effect size, I want to discuss the Q square. Simple definition before you that we are going to check the overall impact of all the independent variable, not impact but the contribution in the dependent variable. So that is the concept of the R square. So the same when we talk about the effect size. So now another paragraph is before you here. It is written that in addition to evaluating R square values of all endogenous construct, okay. So the change in R square value when specified exogenous construct is omitted from the model can be used to evaluate whether the omitted construct has a substantial impact on the endogenous construct. As you know, in the model, on one side there are the dependent, there is a dependent variable, on the other there is independent variable. So now combined we check the contribution of all the independent variable into the dependent variable. Okay. Now whatever the value which we are getting, that is R square. For example, if we are omitting a one construct from that all the independent variable. Now we want to check the how much the remaining R square is there, because sometimes we are deleting a very important construct from our model, but we do not know how much is impacting on the R square. So if it has a substantial impact of the R square, then I think that is a big mistake. That means when you are going to remove that construct, which is the very substantial impact or contribution in R square, and sometimes we are keeping that type of the construct which has almost no contribution in the R square. It is better to read that type of the indicator, that type of the construct which has no very bigger contribution in the R square. So that is the job of the effect size F square to tell you that which indicator or which countries has the what type of the contribution in R square. Okay, and this is the formula which are looking how to calculate the F square. So now, for example, R square included minus R square excluded over 1 minus R included. So now what do you mean the excluded and what do you mean the included? We are getting the concept right now. Here you're looking, it is estimated that the first time with the exogenous latent variable included in the R square, okay, the first time whatever the independent variable are there, okay, in the model, is the first time, and whatever the R square you're getting. For example, your R square is 52% by including all the independent variable in the model. Okay. Now the second time with the exogenous latent variable excluded, Okay, and after that, whenever you are excluding any independent variable from the model, then definitely the R square will be reduced. So now that reduced, that is the R square excluded. Earlier, the actual R square was included, and after exclusion, any of the your independent variable, whatever you are getting the R square, that is called as a R square excluded. Okay. Guideline for now, some of the guidelines are there. Guideline for assessing F square are that the values of 0.02, 0.15, and 0.35 respectively represent a small, medium, and large effect on the exogenous latent variable. Okay, I want to remind you the exogenous means the independent variable and endogenous means the dependent variable. So now here, so now if you are going to remove any construct from the model, if the R square has been reduced, then it change like that between the R square included and the R square excluded. If this change is less from the 0.02 to 0.15, that is a weak, and is from 1.5 to the 0.35, that is substantial, that's a moderate, and above the 0.35, that is a substantial impact is there. Okay, and one more very important is that if the effect size value is less than 0.02, indicate that there is no effect. Okay, so these are some guidelines which are very important to consider in your mind. Okay, now practically we are doing in our smart wheel. Here you're looking a very let me say clean interface of smart wheel. So here we have the demo file, and we're opening it. Double click on demo file. The things are before you. Okay, and what? First of all, we have to understand the in now all the these constructs are the reflective in their nature. Okay, that's very important to consider, either reflective or formative. Depending on that one, we will apply that type of the technique. Okay, and then 361 records are there. So all these are indicators of this model are there. Now we are going to apply it. So first of all, to check the effect size, we have to go into the algorithm. Now all are the reflective. That's why we will prefer to go into the consistent PLS algorithm. Okay. Okay. Now we have to connect. It has the benefit. Please, why I have connected this one? Please read out this whole paragraph and then start calculation. Other things should remain same. Our calculations have been completed. Now, first of all, we have to find out our R square. R square we can find out through the R square here. That is 0.446. There is a substantial contribution of the all independent variable is in the dependent variable. So now the green purchasing behavior is our dependent variable, and that is our R square. Now, the contribution of trust on green products, trust media, price of the green product, and the interpersonal like the promotion and the environmental knowledge. If we combinedly check the contribution of all independent variable in the dependent variable, that is the 0.446. So now an alternative we call 0.446 as an explained variable, explained variance. Okay, and some of the unexplained variances also there. If we include more variable in the model, then probably the R square may be increased 0.446 to the next level. Okay, and then what we should do that we have to check here. R square you can check from here also, and alternative you can go on the report. In the report, R square is available, but we are interested in the F square. In the F square, see here. So now here the different values are there. I want to reduce all these ones. Some are in the green, some are in the one is a black and one is a green. Now, what are these different colors are there? First of all, I would like to talk about these three ITP, media, and price. They are in the red color. Red color means that it has no impact because their values are less than 0.02. So that's why it has no impact. If you want to exclude it, no problem. The R square will remain unchanged. Okay, and then another one is in the black color. In the black color, it has a meager impact. If you remove environmental knowledge construct from the model, then it has a very meager impact, a very little impact on the R square. And those one in the green color, if you delete this one from exclude from this from your model, that is a substantial impact on the your R square. How we will do it practically? Okay, and then why the some of the black, some of the different colors are there? What's the logic behind this? Is then why the what the on which benchmark these have been measured? The benchmark is here in the graph. The beauty of the smart PLS is that it always provides the benchmark here along with this one. So now the 15% are 0.15. So the TGP relationship between the TGP and green purchasing behavior is there is a height in the 0.15. That's why it is in green, and rest are in the I think rest are in the like the red colors. So now they their impact is less than 0.02. So that's why. So EK, GPP, ITP, GPP, and all these are. That is the reason behind the different colors which we are looking here. Okay, now we are going on our model, and first of all, which is the media. We want to first we are reading this media construct from here. This is media. Okay, and one more thing. Let me say these are the paths. If you look at the path, now those where the path are substantial, there now their contribution R square is also substantial. TGP has a substantial impact on the green purchasing behavior 0.489. So that's why it is a very good R squared right here. Now TGP, a good value of the substantial value of R squared is there. Okay. And then just we have to get rid of from these levels. Okay. And then we are removing this one. When you delete it, then you are required to rerun again. So earlier our R square was 446. That means 44.6% was there. And now again we are going to consistent PLS and algorithm. Start calculations. And now going on the R square. So see, the same value is there. Now it has no impact on the R square because the value of that was less than the 0.02. So that's why there was no impact. Even though now you think check that this one. Even if you delete ITP and the price, you will face the same type of situation is there because limited time. I want to I don't want to remove all these, but in your free time you can do the same thing. I have provided a link below this video from where you can download this data, and for practically you can do in your free time. But now I'm going to do remove. I'm going to remove this TGP from this, and then see what if the impact is on the your dependent variable. Just click delete it and then repeat again. Consistency plus. Okay, everything is okay. Just start calculations, and now you will see a magic. The magic in this one that the R square has been substantially decreased. Earlier the value of R square was 0.446. Now it is just 0.293. That means that the R square has been drastically reduced from the 44% to 29%. That is because a very important the indicator or the construct independent variable has been deleted from the model. So in this way, we can check out that all independent variables are there, and we can check out which one has the highest impact, which is the lowest impact. In this way we can do all these things. Okay. As earlier I showed you one formula. Now formula you are looking here. That means that is a handwritten formula is there. In this way, F square, R square included. R square included earlier R square 0.446 and minus R square is excluded. When we excluded the two our variable TGP, another one, now our R square has been reduced up to the 0.239. Okay, minus and over 1 minus 0.446. The result is what? This the 0.554. And the result, when you solve this equation, our result is the 52. That is the by removing this one your construct, that means that it has a negative impact. That our R square has been reduced up to the 52%. Alternatively, our 46%, and now it is at 32 and 29%. If you get the difference between these, it will in the percent it will be 52%. A quite heavy impact is there. So that's why it's very important to calculate all these things. Okay. So next step is our blindfolding and predictive relevance Q square. So it's very, again, to have some theoretical perspective. Now you're looking here. In addition to evaluating the magnitude of R square values, as already I have done, there's a criterion of predictive relevancy. Research should also explain the Stone Geyser Q square. So now, along with the R square, we should also focus on the Q square. What is the benefit of the Q square? This measure is an indicator of the models out of the sample predictive power or predictive relevance. So now, basically, dear friends, the job of the smart PLS is to increase the predictive power. So up to what level this model is predicting. So that's the job of the smart PLS. So that's why it's focusing on the maximizing the R square. Okay, if you compare with the MOS is working on the theory testing. So nowadays, by considering the high demand of theory testing, the smart PLS people who are working for smart PLS, they're also keeping some of the. They're also working that how the people can also test their theories into the smart PLS. Okay. Now another one is that this measure is indicated. Okay. Another is that in the structural model, Q square values larger than 0 for a specific reflective endogenous latent variable indicate the path model's predictive relevance for the Q square dependent construct. So now the benchmark is there that if the value of Q square is more than the 0.000, that means it has a predictive power. Higher, the larger the Q square value, higher the power of the prediction. And then another thing is about the blindfolding. Now, how to calculate the R square? The procedure to calculate R square is a blindfolding. Okay. Now, the blindfolding is a sample. Now, what is the concept of the blindfolding? Okay, I'm giving you. The blindfolding is a sample reuse technique. Is a sample in this way. Again, you are using the same technique that omits every data point in endogenous construct, indicator, and estimate the parameters with the remaining data points. So now what it does, it omit one particular item from your data, one indicate like the data point from your data, and then start computation again from there. For example, if you go into the smart PLS right from here, so this is a blindfolding. In the blindfolding here, you are looking here, the values are the 7. But okay, if you read this one, why 7 is there? An omission distance of the 7, d equal to 7. Now distance is 7. For example, implies that every 7 data point is the target of the construct indicator are eliminated in the single blindfolding round. In the single item, in the one round, it deletes every 7th item. For example, if the data points are 300, then it will delete the first 7th, then 14, then 21. In this way, the process will go on until the software is not reaching on the 300 sample size. Since the blindfolding back procedure has to omit and predict every data point in the indicator used in the measurement model of a certain latent variable, it comprises of 7 blindfolding rounds. At the end, it provides 7 blindfolding rounds there, and hence the number of the blindfolding rounds are always equal to the omission d. Okay. Now, alternatively, we can also choose the different levels. Now, from 5 to 10 we can, but normally it has been suggested to us that we should focus on we should have a 7 instead of anyone. So we are closing down this one. Okay. And then the omitted data points are considered missing values. Now, whatever that 7, every 7, if the software is deleting, now software consider that if this deletion is a missing value or missing point. So now how it treats it treats like by filling it by the pairwise deletion. Now either the software delete it pairwise or it replaces the deletion or delete point blank point with your mean replacement. Now it replaced with the mean over there. So that's another thing. Okay. Another thing you're looking at the difference between the true omitted data point, okay, actual data point, and the predicted ones. Now the new data which has been calculated after deleting a particular 7th item. Okay, the blind form is an iterative process. It's repetitive process are iterative or repeated, both are same. That repeats until the each data point has been omitted and the model re-estimated, until all data points have been omitted up to the level of your sample size, and now the model has been re-estimated. Till that time it will continue its iterative process. The blindfolding process is usually applied to the endogenous construct and that have respective measurement model specification as well as the endogenous single item construct. So that's very important. The endogenous means a different variable. Now, blindfolding technique we can apply when we have our model. That one is a dependent. When our dependent variable is a reflective, okay. If our dependent variable is a single item construct, but that should also be the reflective. In this situation, we can apply blindfolding. So, blindfolding technique we cannot apply on the formative dependent variable. So that's a one type of limitation of the blindfolding technique. So here, all our actually our dependent variable is a reflective. Like from this one, that's a reflective. So that's why on this we can apply this type of the blindfolding technique on this one. So now let's start to apply this blindfolding technique on our model. So before applying this technique, first of all, we have to look at that the either dependent variable is reflective or not. So it is a reflective. That means blindfolding technique we can apply on this type of the data. Okay. And now how to do this one? Go into the calculate and just go on the blindfolding. Then the 7 is there. Now the range is from 5 to 12. Here you're looking here. The range is from 5 to 12. Okay. So now we are applying the 7. Is the most of the time the 7 is being applied, and the 7 is also recommended. That's why we are also applying 7. And then simply start calculations. So our calculations have been completed. Now we are looking at our cross construct cross validate redundancy. In this, we are looking here that the Q square value is appearing here. So now this value 0.135, underneath we call the 13.5% is that means significantly above the 0. It means it has a good power to predict the model has a good power to predict. So now how the value has been calculated, that's very easy. That means how this value has been calculated. The value has been calculated by the SSO and SSE. So now the Q square has been calculated by equal to the 1 minus SSE and divided by SSO. That this variable has been calculated. So now this variable shows that we are quite higher than the 0.001. So that means that it has a good predictive capability to this model. Okay. And the last one still is there. The last one you're looking here, that's about the effect size Q square. Like the already we check about the effect size of the R square in the shape of the F square. Now the same thing we are doing here. So now we will not do everything. We will do the manually right now. Now first of all, what is Q square? What is the effect size of the Q square? The Q square value estimated by the blindfolding procedure represent a measure of how well the path model can predict the originally observed values. Okay, now it's clear. And then the similar to the F square effect size approach for assessing the R square value, the relative impact of the predicted relevance can be compared by the means of the measures of the Q square. q square effect. The formula you're looking here, q square equal to the q square included minus q square excluded and 1 minus q square included. So this is a formula you can do practically on the piece of the paper, and that means you can get to know about what is the level of the q square right now. Dear friends, here I would like to end my this video lecture number 15 part B. In this way, all the you're looking at the 6 step I have covered in the part 3. I covered the first 3, and in this one I have covered last 3. I hope again this video has been proved as a useful, fruitful for you. And please take care of yourself, and please take care of this channel also by watching it, by subscribing it, by referring to your friends to this channel. Thank you very much for your watching this video.